have a selfie stick.
We have 3 people so far. Yeah. We have 8 people on so far, so.
Hey guys, sorry, I'm just trying to share this to my Facebook page real fast and then we will get started. Just me. Hi everybody, welcome back to our weather school here for our Wednesday at 1 o'clock on Facebook Live. We've got Instagram going as well as Facebook, so thank you guys to behind the camera, Hannah and Brett, making sure we get this out to everybody. So we're going to do some simple stuff today. I think you'll be able to do at home, but we're talking all about sunlight and what it does for us and some of the different colors that we see out of it. And I've got a couple tools to show you to use. First, if you want to do these things at home, you're going to need a flashlight. If you happen to have a prism, this is a really fancy one that Marina Newman left me to use today. One of our photographer friends has this. You can see some of the colors I'm talking about, but you can even do it as simply with maybe a glass jar or a vase and some water. So we're going to get a chance to look at the colors that come from the sun, but we're going to use this as our sunshine for today. So let's start off here with just kind of what we're going to go over today. We're going to answer a couple questions. Why is the sky blue? What makes a rainbow? And why are the sunsets red? If the sky's blue during the day, what's different in the evening or in the morning that allows the sunrise or the sunset to change color? So let's start off with this. Just kind of some fun, fast facts for you. The sun is let me see here. The size of the sun is really just enormous. We've got this beach ball here that is our Earth, and just for a little bit of comparison, the sun could hold 1 million Earths inside of it. So it is enormous, so much bigger than our planet and bigger than the Earth. So just a little bit of scale, if we had 1 million of these, they could all fit inside of a sun that was to this scale. So incredibly big. Not big when you consider some of the other stars in the galaxy and in the universe, but for us, compared to Earth and compared to the rest of the planets, it's huge. It takes, because it's so far away, 8 minutes for the light from the sun to actually get to us here on Earth. So when you're looking up outside and you see the sun shining, that light actually left the sun 8 minutes ago. But because the sun is about 93 million miles away, it takes all that time for the light to actually get down here to us, down here on the ground. The sun's core temperature at the very middle is up to about 27 million degrees. Deep inside the middle of the sun, that's where we have hydrogen atoms turning into helium atoms. And that is what creates all the fuel for our sun, and that's what puts off all that heat. There's nuclear fusion going on inside. On the surface, the sun is actually just up to around 10,000 degrees Fahrenheit. So a lot hotter in the very middle, but still really hot on the outside. But about 10,000 degrees, a number you can wrap your head around a little bit more. And lastly, again, we talked about that a little bit in the middle. It is made up of hydrogen and helium. There's still a lot of hydrogen left in the sun, and basically that's the fuel that's turning into helium, and that's what creates all the heat and what we see. Now, this is a little bit scientific, but we kind of have to start here, at least look at this, in order to jump in. I see Hannah making a face. I'm not sure if it's related to this or not, but the light from the sun travels in waves. You can kind of picture it like this, the same way waves in the ocean, but we've got all sorts of different things that are coming from the sun. We've got X-rays, ultraviolet rays, the things that give us sunburn, visible light, the thing that we can actually see, and then infrared, microwave, even the sun is emitting some radio waves. Not, of course, a radio wave that you can tune into, but still pretty wild. This gives you an idea of the different sizes. Visible light is closer to basically what we call a protozoa, but a really, really tiny, small, microscopic little animal. Molecules are closer to ultraviolet size, but this here is the section that we're concerned with. That's the section of the light spectrum that our eyes are actually able to see. So light from the sun to us looks like it's all one color, looks like it's white. But what actually happens here is all of those different colors come from the sun at the same time, so when we get them in our eye, it looks like one white color. What we're going to try and do today is separate that white light into its different colors. This here is one of my favorite pictures that kind of shows this. I don't know if you guys need to zoom in at all, but what I want to point out here on this is that we've got red all the way down to violet, and those are different wavelengths coming from the sun. I know, again, this is a little scientific, but that's what allows us to separate these different colors. So most of the energy from the sun is coming to us as visible light, about 44%. Then again, there's some X-rays, some UV rays, the radio waves, but we get that visible light, and that's what does most of the works most of the magic down here for us on planet Earth. We see it as white, but it's actually made up of all the colors of the rainbow. So what happens when we use a tool like this, we call this a prism, which we're going to try and use our own right here, is it separates the white light into its different colors. First, it does what we call refraction. Basically, it bends the light as it works its way through the air and then into our piece of glass. But then the second part that happens is called dispersion. And that means that the different wavelengths are going to react differently. Let's take a look at it. It's probably a lot easier to see than maybe it is to understand when we talk about dispersion and refraction. So we have here the same sort of thing. We've got our prism, and I've got this light. Of course, it's not the sunshine, but it's still pretty bright. This is, sorry, Brett, right in your eyes, an LED light, but it is generally white. It's really close, maybe not a perfect white. But what we're going to try and do, you guys might have to get closer, and I'm going to have to mess with this a little bit, is we're going to shine our light through this prism. It's not really bright, guys, because we have all the studio lights on here, so I apologize about that.
I'm going to cut lights real quick.
But we might be able to.
Yeah, I guess that's
we've
quick.
got, that's okay, I wouldn't worry about
Sure,
it, Brett.
cool.
Yeah, so this is something that you guys will be able to see at home too, but if you kind of come in a little bit closer, what I want you to see here is this arc right in the middle. Let me spread out from my paper a little bit. And you can see here our white light going in. There's still some white light, but on the more middle part of that paper, you see kind of looks like a rainbow. And they're faint. If we had the lights off, you'd really be able to see them. But we have all the colors of the rainbow. We go from red, orange, yellow, green, blue, indigo, and violet. So that Roy G. Biv saying that maybe you've talked about in school or you remember learning in school a long time ago. So what we're trying to do is use this prism to separate the white light out into those different colors. And that's exactly what's happening. The light's going into the prism, it actually gets bent a little bit, and that's the refraction, but then the dispersion is what separates those colors into their different pieces. That's the same sort of thing that happens in the sky when we have a rainbow, and then also it's part of the reason we see a blue sky. One of the reasons here, let me switch over here, we'll start off with why the sky is blue. And Brett, right behind you, that beach ball, can you just roll that over to me? A lot of people, I think even when I was little, I used to think that the sky was blue because the water from the ocean was actually reflecting back up to the sky. That's actually not true, that's a myth. And you can see why people might think that. There's a ton of water on the globe. The oceans take up about 70% of the Earth, but that's actually not what's going on. Sunshine, just like we have here with our flashlight, is shining into the Earth here with all the colors of the visible spectrum. So that means Roy G. Biv, red, orange, yellow, green, blue, indigo, violet, they all shine down together. So for us it looks white. And you can kind of see here that what happens, that white light runs into our atmosphere. Here's the planet, here's our thin atmosphere, or the sky around our area. And then what happens, as it hits the atmosphere, this is where it gets a little scientific, it passes into all these different things in the air, these different gas molecules, maybe dust, maybe some pollution, some pollen, and as it bounces into those things, it gets scattered. So let's dive in here a little bit closer. We've got all of those colors coming in together, but we end up really only seeing in the sky the blue color. So what happens? That sunlight comes in, it hits these teeny, tiny gas molecules or air molecules, and it basically scatters that blue light in all directions. And you have to imagine that there are billions and trillions of these gas or air molecules up there in the sky, And all of those happening all over the place all at the same time scatter just the blue light. Down here for us, we end up still seeing the red, the orange, the yellow, the green, but we see all of them together that don't get scattered, and that's why the rest of it still kind of looks white. So here's kind of what's going on. The air molecules and other things in the atmosphere, or other things in the sky, like the dust, the pollen, all sorts of stuff floating around up there that we can't see with our eyes. It's just way too small. It scatters that blue light. It basically hits it and then bounces off in all directions. And then it makes it makes it look like blue light is coming from everywhere in every direction. So what it does, it takes that white light, like we had here with our prism, and it separates the blue specifically and just shines it off of everything. Now there's a little bit, if you can see I drew them really small, it's because it's a really small amount. There may be a little bit of red light or green light that gets scattered in the atmosphere, but because it's so small, it's so little, everything still overall looks blue to us. So it's not the reflection of the ocean, it's actually the air molecules floating around up there that work to disperse and work to scatter all of the sunlight, but really focusing in on the blue wavelengths. There's actually a little bit of purple that gets, or violet that gets scattered in the sky as well, but our eyes are just more in tune to blue than they are violet, so even though the sky might actually have a little bit of purple color floating around, we don't really see that as much as we do the blue. So what's the difference? Why do sunsets look red? You have to imagine that you're standing here on the earth, when you look up at the sky and you see the blue sky, you're looking straight up. So you're not looking through a whole lot of atmosphere, just a few miles. But when we see sunsets, when the sun sinks down lower and lower on the horizon, we're looking through a lot more atmosphere. So this picture kind of shows it for you. You're looking up when you see the sun there, but then when you're looking farther out throughout the rest of the sky, you're going to look through more and more atmosphere, more pollution, more pollen, more dust, and what that does is actually create our red sunset. So let me switch over here to the next thing, the sunlight traveling through more of the atmosphere, and what happens, that blue light that we were talking about before that gets scattered when we look up and we see our blue sky, it basically gets completely scattered when we have a sunset. We don't see it at all. Back for people who are closer to the sunset, basically when the sun's higher in the sky, they still see the blue. But for us, when we're looking at the sun setting on the horizon, it's pretty much all gone. We don't get really any blue light making it to our eyes. Even some of the yellow light gets completely scattered out. Basically what I mean is it just gets fainter and fainter and fainter, and we just don't see it. The red light, however, that is the least impacted by all the dust, all the pollution, and that's what actually still makes it to our eyes. This is kind of tricky, but the big difference here is when we're looking up at the blue sky, there's just not a lot of atmosphere up there. It goes basically up about 10 miles, 20 miles, but then when you're looking through the atmosphere over toward the horizon at sunset, we have a lot more molecules to get through, and that's why things turn red. Same sort of thing happens during the day. You know, when you look straight up, the sky is a lot bluer. As you look more and more over toward the horizon, it starts to get paler, and it gets whiter, and it just doesn't have that same bright blue. So again, this is a little bit complicated, but the biggest difference is just how much air the sunlight has to go through before it gets to your eyes. So here you can see what kind of happens. The purple, the blue, the green, the yellow, the orange, everything gets filtered out. And what's left for us at sunset is really just the red getting here. During the day, you look up, it's the blue that we see the majority of, but later in the evening or early in the morning, you can see here as the sun sinks down, we just get less and less of those colors and more of the red making it to us. So again, I know this is a little bit of a tricky one. How about this? How about rainbows? This is basically our prism that we just did, but on a scale the size of the sky. So this picture, I grabbed this from Twitter. Lauren Garner, I don't know if you're watching with kids maybe, but she tweeted this from Lake Murray the other day, and we had a really pretty rainbow out there. And this picture I thought just really kind of helped to draw what's going on. So for us with our prism, we're shining the light through, it gets bent, it gets dispersed, and we end up with all those colors. The same sort of thing happens in raindrops as well. So the sun shines in, it bends it, it refracts it, and it disperses it into its different colors, and it reflects off the back of the raindrop and then comes out the other end. Now when it comes out, we've got all the colors of the rainbow: red, orange, green, yellow, blue, violet, indigo. So we've got all of our Roy G. Biv colors. But it's not just one raindrop doing this, it's millions and billions of raindrops that are doing this up in the sky. So we've got all these up here, all reflecting all of the colors of the rainbow back to it. So let's imagine we're down here, the sky is a little gigantic here, it's not really drawn to scale. But what happens is different raindrops are going to give us different colors. So if we kind of draw some lines here from this, some raindrops up higher in the sky are going to reflect the blue light back to his eye, and then raindrops that are a little bit lower are going to reflect the red light back to his eye. So because of that, different raindrops giving us different colors, everybody's rainbow, if I look at one standing right next to you, it's actually a unique rainbow to me and a unique rainbow to you because it's different raindrops that are reflecting those colors back to our eyes. So it's kind of neat. Rainbows, we're all looking up at the same thing, but it really actually looks just a little bit different to each one of us. Now, as these raindrops fall through the sky, it'll be different raindrops that give you your rainbow as well. So, kind of break it down for you. Different raindrops reflect the different colors back to your eyes, and the rainbow you see is going to be different from somebody else's, even if they're right next to you. Zooming back out here a little bit, there are a few rules to actually be in a position to see a rainbow. First, there has to be sunshine and there has to be rain. And you have to be in between the two of them. So you have to have the rain clouds and the rain maybe in front of you and the sun behind you. You've got to get yourself in that position because we need the sun to shine past us into the raindrops and then have it reflect back to us. And this picture here actually has a little bit of a double rainbow, and that's just when you end up with four reflections inside the raindrops. So pretty wild. Sun has to be pretty low in the sky as well. It's not going to happen during the middle of the day. The sun has to be low enough that we're able to see that reflection bounce back to us. If it's noon and the sun's out somewhere and we end up with some rain, not going to see any rainbows. What you might be able to do though is maybe with the hose or the sprinkler, that sort of thing, you'll be able to see a little rainbow created during the middle of the day because you can point the water where you need it to go. So let's try and make our own rainbow here really quickly. This again is a little bit tough for us to do because we have all these bright lights on here in the studio. But what you need here is going to be a glass of water. You can use a bowl of water, but I'm going to use this vase here. And then you just need a mirror. We can't really easily get the water to reflect the light back to us like it does in a raindrop because you've got the individual drop, and that's what allows it to reflect back. But here in all this water, it doesn't work as well. So we put in a mirror to kind of give us that reflection, and the water is still going to be what does the refracting and the dispersion of the colors. But let's see if we can get this to work. It is a little bit tricky. So when you try this at home, really you're better off going into a darker room, maybe try in the bathroom, and you can just, depending on what angle your mirror is at and what angle you hold the flashlight at, you'll get your, I have to not shake the table, you'll get your rainbow to show up in different areas. So let me start off here. I just had it and now I've lost it just like that. A little bit here. Again, ours is very washed out because of the color of the, because of the bright lights in here. What just happened to it? It was working so well. There we go. A little bit right there, right kind of at the tip. You can see this a lot better in the dark. So what I would recommend here is you try with different size glasses and in a darker room as well. There we go. There's a little bit. So this part right here, it's a little tough to see, but you can see here the red on the far end. As I shake the table, it gets a little tougher to see. The red on the far end, and then the blue as you go down. So it's kind of a little cheat to me. Let's see here if I go a little farther out. It's a little bit brighter. But you'll notice here as you move your flashlight, or you can even just do this with a phone. The flashlight on a phone is enough to do this. But as you move your light in and out, get farther away from the mirror, you can see that color getting separated. So again, this is what happens when we have a rainbow in the sky, except instead of a mirror, it's just reflecting off the back of the raindrops. Sorry guys, I keep moving it on you, trying to make it a little bit better. Let's see here if I go like that. But again, a prism, if you have anything in your house, maybe if you have anything that kind of like little, basically supposed to be little diamonds, that sort of thing, or even with a diamond ring, you'll get that same thing that happens. The light comes in, it gets refracted, and then reflects back out, and you can end up with some really wild rainbows kind of sparkling all around the room. But if you happen to have a prism or any sort of fake little jewels, even will work. It doesn't have to be an actual diamond. This here is made of, they can either make them out of glass, out of plexiglass, can just be plastic. But really, an easy thing to do, just need a little mirror, need something to hold your water, and you just kind of have to be patient because it does take a little while to figure out exactly the right angle to get everything to show up. But that is ultimately what it's all about. We've got the sun shining down, all sorts of different wavelengths of energy, but the ones that we see are going to be the visible light, and that's going to be everywhere from Roy G. Biv, from your red, orange, yellow, green, blue, indigo, and violet. And then what we're trying to do here is break them down. When they show up all together, it looks white, but when they show up, when we separate them, we can see all those different colors. I'll get that to work one more time. This is a nice little prism that she got, that Marina gave to us. So you can see here a little bit there. Oh, whoops. All those colors in there, but then even better here, you can see kind of how we separate the light out in that area right there. So hopefully that's something you guys can mess around with today. And if you've got sunshine in your area, it's certainly easier just to hook up the hose. And if you can get it on some sort of mist setting, you can easily get a rainbow to fire up for you. And it's the same thing that happens in the sky, just on a smaller scale, and kind of point it where you guys want. Next week, we're going to talk about hurricanes. We get closer to the beginning of hurricane season. Of course, hurricanes don't have to start and stop inside hurricane season, but it does officially begin June 1st. We're actually already tracking something out there in the tropics closer to the Bahamas, so we'll have more on that for you. Not going to be an issue for us on the East Coast because that thing is going to continue to go out to sea, but still just in the middle of May and already talking about maybe a tropical disturbance setting up. If you guys have any questions, you can post them there in the comments. I'll look back through and get a chance to check them out and hopefully answer some for you. But otherwise, hopefully you enjoy it, can enjoy some nice sunshine over the next few days. And if you do any of this stuff outside with the sun, it's just going to magnify it and make it look even cooler. So a flashlight or your phone will work, but if you can take your prism or something that's like a prism and use actual sunlight, you get even more vibrant rainbows out of it, so it's pretty cool. Thanks for tuning in, guys. I hope you have a great rest of your day and a great rest of the week.